So dear students, in this video we will see the topic on finding complementary function of linear ordinary differential equations with constant coefficients. This presentation is based on the book Mathematics 2 for B Semester 2 by Dr. Shailesh Patel, Atul Prakasam. So friends, we have already studied first order differential equations, in which you have seen different methods like method of separation of variables, homogeneous equations, linear differential equations, and exact differential equations. In this, you have seen linear differential equation in the of order first. So it was in the form of dy by dx plus p dy by dx plus qy equal to rx. But here we will see higher order differential equations to solve. You can see here the general form of nth order differential equation is d raised to ny by dx raised to n plus an minus 1 d raised to n minus 1 y by dx raised to n minus 1 plus dot 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 plus a1 dy by dx plus a0y equal to rx. Rx means the right hand side function. Here the coefficients of all the derivatives an minus 1, a1, a0 are constants. Like second order differential equation we can write as d square y by dx, where plus a1 dy by dx plus a2y equal to rx. So these kind of equations we need to solve. So here first of all, let us see the general form of differential equation can be written into the form of capital D. Here capital D is d by dx. D square means d square by dx, where d cube means d cube by dx cube. So this form, general form of differential equation, can be written in the form of d as this, and after simplifying we can see that it is the polynomial y when y is taken common. So we can write finally it as f of dy equal to rx, where f of d is the polynomial which is written here in the bracket. So to solve this equation, we need to solve this equation into two parts. The first part is by considering the right hand side equal to 0. That means at the first level we will consider right hand side rx equal to 0. That means by considering f of dy equal to 0 and solve the equation. And the solution of this equation, that is by taking rx equal to 0, we will call this equation, this solution as complementary function or homogeneous solution. And in the next part we need to solve the same equation by considering rx as it is. That means then we will write down y equal to 1 upon fd rx, and then we will solve. After finding both kinds of solutions, first complementary function, and in the second part whichever the solution we will obtain is known as particular integral, then we will add these two solutions to get the general solution, that means the final solution. So here first of all we will see how to find out the first part, that means by considering right hand side equal to 0, and that means the solution homogeneous solution or complementary function. So this nth order differential equation can be written into the form of D. After then we will, this equation has n different solutions, y1 y2 dot 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 yn, and the combination of this solution can be written into form c1 y1 c plus c2 y2 plus dot 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 plus cn yn, that c1 c2 c3 dot 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 cn are arbitrary constants. So this solution will give us the complementary function. So first let us see how to solve complementary function. And here you can see y can be written as cf plus pi. Pi is the second part, cf is the first part, which we want to see now. So method of finding complementary function. So after writing whatever the equation is given to us, first of all consider its homogeneous part. Homogeneous part means by considering the right hand side equal to 0. Then write down this equation into the form of m. Here in the last line you can see m raised to n, that is by replacing d by m. M raised to n plus an minus 1, m raised to n minus 1 plus dot dot plus a1n plus a0 equal 0. This is nothing but nth degree polynomial, and whenever we see a solve nth degree polynomial, then we get n roots, and the procedure of finding n roots is very easy. This already comes in the school level. So here actually we will consider, mostly we will consider in this chapter, in this topic, second order, third order differential equations. So hardly we need to solve, we need to find out 2 or 3 roots whatever it is, whatever it is. So the roots, we know very well that there are three kinds of situations arises. That means the obtained roots are all real and distinct, or all roots are real and equal, or the roots are imaginary. So we will consider here three cases. The first case is when the roots are real and distinct. So if the roots obtained m1, m2 dot 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 mn are all distinct, then the solution can be written very simply. That means we will denote the complementary function. That means homogeneous solution as CF, YC. That means YC equals C1 e raised to m1x plus C2 e raised to m2x. That means write down the roots m1, m2 in the power of e together with x. So we get complementary function very easily. For example, here you can see the illustration. The example is given in the form of b square minus 7b plus 12 bracket over y equal to 0. Here the equation is given directly in the form of capital D, but actually capital D is d by dx. D square is d square by dx square. So if we are given in the form of dy by dx, then also we can convert this in the form of capital D. So the characteristic equation is very easy to write down. Characteristic equation means the polynomial when we obtain by replacing d by m. So here we can write down this as m square minus 7m plus 12 equals 0. After factorizing this, we can get m minus 3 into m minus 4 equals 0. That means the two different values of m we have obtained here, 3 and 4. So the general solution is y equals c1 e raised to 3x plus c2 e raised to 4x. So here you note that we have written here the general solution, not as yc, because the equation is directly given by taking rx equal to 0. No value of rx is given, so no need to solve this equation into two parts, because right hand side is already 0. But if right hand side is some other function, then we need to go for second part. Then the second case, when the roots are equal. Suppose at the present level we assume that the two roots are equal, m1 and m2. That means m1 equal to m2, and all other roots are distinct. That means different roots. So if the roots are equal, two roots are equal, then we can write down the solution in the form of c1x plus c2 into bracket over e raised to m1x, and all other roots can be written into the form of the solution as this, as in the first case. If three roots are equal, then we can write down this as c1x square plus c2x plus c3. So the number of constants is exactly equal to the number of roots. So let us see one example where we are given the example 4d square y minus 4dy plus y equal to 0. So the auxiliary equation or characteristic equation can be written as, here you note that we can also call characteristic equation as an auxiliary equation. So here replacing d by m, we can get 4m square minus 4m plus 1 equal to 0. After factorizing this, we can get two different values of m. This is 1/2 and 1/2. So the general solution is very simple. Y equal to, two roots are there, so we will write down c1 plus c2x. If three roots are there, three roots are equal, then we can write this as c1 plus c2x plus c3x square. But here are only two roots are equal, so c1 plus c2x bracket over, then e raised to 1 by 2 into x. So this is the solution. It is also very simple. Then the third case, when the roots are complex, that means imaginary. So imaginary root always exists in pairs. That means if one root exists in the form of a plus ib, then there always exists second root a minus ib. So we will consider the pair as a plus or minus ib also. So in this case, the solution is written very simply. Identify the values of a and b from a plus or minus ib, then write down e raised to ax outside and into bracket c1 cos bx plus c2 sin bx. That's all. The other part can be written depending upon the case of case 1 and case 2. But simply here the solution is written in the form of cos and sin. So now let us see some of the examples. See here the illustration. D square plus 1y equal to 0. The auxiliary equation is m square plus 1 equal to 0. So if we find the roots, we can get m equal to plus or minus I. So if we compare this with a plus or minus ib, then we can get a equal to 1 and b equal to a equal to 0 and b equal to 1. Therefore the general solution y is equal to, actually outside it is e raised to ax, but a is 0, so e raised to 0x, that means it is 1. So we will have c1 cos bx, but b is 1, so c1 cos x plus c2 sin x. This is the solution. So it is very easy to solve. Now let us see another example. Solve y double dash plus 2y dash plus 2y equal to 0. See here, the equation is written in the form of y instead of capital D. So no problem, because we can write this into capital D form as easily. So here you can see we have written this as d square for y double dash plus 2d plus 2 bracket over y equal to 0. Here in the example we are given y0 equal to 1 and y of pi by 2 equal to 0. These are the two conditions. These two conditions we will use after obtaining the solution of the given equation. Before of that, no need to use these two conditions. Actually, these two conditions are to determine the values of arbitrary constants C1 and C2 which will arise. Here once again you remember that if we are given second order differential equation, then its general solution, two arbitrary constants will be there. If it is third order differential equation, then there are always three arbitrary constants C1, C2 and C3 and so on. So if we solve this equation, then we can have the characteristic equation, means auxiliary equation is this, and if we find out the solution m roots m by using minus b plus or minus root b square minus 4ac divided by 2a, we get minus 1 plus or minus I. So here you can see that a equal to minus 1 and b equal to 1. Therefore the general solution is y equal to e raised to minus x, because in the formula we have e raised to ax, but a is minus 1 into bracket c1 cos bx, b is 1, so cos x plus c2 sin x. Now the solution is obtained, but we require to use the two given conditions. So one by one we will use this condition. First we will use the condition y0 equal to 1. So here we will write given that y0 equal to 1. So in equation 1, this is the equation number 1, so that means the solution. If we put here y0 equal to 1, that means here x equal to 0 and the value of y is 1. So we put x equal to 0 and y equal to 1 in the solution. So we get here y equal to 1, y equal to 1, here e raised to 0 means 1, c1 cos 0 is 1, sin 0 is 0, so c1 equal to 1. Then we use the second condition, y of pi by 2 equal to 0, that means x equal to pi by 2 and the value of y is 0. So if we put the same values in the same solution 1, we get 0 equal to e raised to minus pi by 2 to c2, that means c2 equal to 0. So the values of c1 and c2 have been obtained, and then substitute these values in the solution, equation number 1. So we get y equal to e raised to minus x into cos x. So this is very easy to solve. Let us see another example. You can see here second order differential equation is given together with the two conditions, but conditions we will see after obtaining the solution. So first we will focus on the given equation only. So the characteristic equation can be written directly as m square minus 5m plus 6 equal to 0. If we solve this, we can obtain the values of m2, m3. This you can see that both the roots are distinct, that means different. So the general solution is y equal to c1 e raised to 2x plus c2 e raised to 3x. So it is as in case 1. So we now use the solution is obtained. So now we will use the conditions one by one. So here the first condition is given in the form of y1 and second condition is given in the form of y dash. So here y dash, to use the second condition we need the derivative of the general solution. So at initially we will obtain its derivative, that means y dash equal to c1 into 2 e raised to 2x plus c2 into 3 e raised to 3x. Now we will use the first condition, that means y1 equal to e square, that means here x equal to 1 and y equal to e square. So if we use this condition, we can have this equation. We have not obtained the value of c1 or c2 directly, so we will consider this as first equation. Then second condition we will use y dash 1. So in the derivative y dash we will put x equal to 1 and y dash equal to 3 e square. So hence we can get this kind of equation. If we solve these two equations by using the equations ax plus by, a1x plus b1y equal to c1 and a2x plus b2y equal to c2, by using this procedure we can obtain the value of c1 equal to 0 and c2 equal to 1 upon e. So the required solution is y equal to 1 upon e raised to 3x. So friends, it is very simple to solve this kind of differential equation, and it has the weightage of 3 to 4 marks, so you can obtain this solution very easily. Also this part of solution will be used to us in the second part, that means when we will find out particular integral. So as another example, here you can see that the third order equation. So first of all we will write down auxiliary equation, m cube minus 6m square plus 11m minus 6 equal to 0. So obviously this is third order polynomial, so it will have three roots. And to obtain three roots, we cannot find the roots very easily. So we can first root we can obtain by using the process of trial and error. That means we try to put m equal to 0. If both sides will become 0, that means 0 equal to 0, then we say that m equal to 0 is the solution. But here it is not possible. Then we try to put m equal to 1. So if we put m equal to 1, here you can see easily that it will become, left hand side will become 0. That means 0 equal to 0. So m equal to 1 is one root. M equal to 1 is root. So m minus 1 is the factor. So here we have taken m minus 1 as one factor in common. Then in second bracket, obviously m minus 1 if we take outside, then in the another bracket it will remain second order polynomial. So we will start with m square. So m square into m means m cube. So here it is m cube. Then here in the equation it is given minus 6m square. But here m square we have substituted. So with minus 1 it will give us minus m square. So with comparing this with minus 6m square, it is remaining minus 5m square. So here we will put minus 5m. So m into minus 5m means into minus 5m into m is minus 5m square. We have all obtained. Then here minus 5m into minus 1 means plus 5m. But here we want 11m. So we need 6m. So we need 6m. So here we will write down plus 6. So already we get here 6 into m means 6m and minus 6. So last term has been obtained. Then this quadratic part we can solve as very easily by factorizing or by using the formula minus b plus or minus root b square minus 4ac divided by 2a. So here we have obtained the three different roots 1, 2 and 3. Then the general solution is y equal to c1 e raised to x plus c2 e raised to 2x plus c3 e raised to 3. So here you can see that the third order equation is there. So three arbitrary constants exist. Another example you can see, this is the second order differential equation, but here you can see that instead of y it is written x. So in other problems likewise this, here we were using y. Y means we were using the capital D as dy by dx. That means y is dependent variable and x was independent variable. But here in this example x will act as dependent variable, and we are given already here that capital D equal to d by dt means t is independent variable. So we will obtain the solution in the form of x equal to something. That means x as a function, x equal to function of t. So only variable change is here, nothing else is different. So first of all, auxiliary equation is m square plus 6m plus 9 equal to 0. We obtain m equal to minus 3 and minus 3. That means repeated roots, equal roots. So the general solution is x equal to c. Here you must remember that we will write here x, not y, because y is not given here. Here only x and t are given. So two roots are equal. So we will write down c1 plus c2t. See again, once again here you remember that don't write x here. c1 plus c2t bracket over e raised to minus 3t. So this is the solution. So we can solve the homogeneous part of the equation by considering the right hand side equal to 0. Here in this part, whatever we have seen in already right hand side was given as 0. So we have not written this the complementary function as yc. Simply we have written this as y because it is the general solution. But in the second lecture we will see when right hand side is not equal to 0, that means it will be given as some function of x. So then we will require to solve this into two parts, first complementary function and the second part as a particular integral. So then there we will write down by considering right hand side equal to 0, instead of y we will write there 1c. So here are some of the examples for your practice. You can practice yourself. Answers are also given. The equations are very simple to solve. Here in the third equation example, you can see that the fourth order equation is here. So four different roots will be there. And in the answer also you can see that there are four different constants c1, c2, c3 and c4. So you will be asked in the examination the equation by directly giving right hand side equal to 0 of 3 or 4 marks. So you can get 3 to 4 marks very easily, and you will also be asked another equations by considering the right hand side equal to rx, that is some function of x. There also this technique will be useful. There also if you solve one part, then half of the marks you will get easily. So friends, you practice yourself some of the examples which are displayed over here, and you can solve. If you will find any query, any difficulty, or any problem, you can contact to me directly, so I can solve your queries and I can help you. Thank you. Thanks, Prem, and see you in the next lecture.